Let's talk about Boyle's law, that is concerned with the effect of pressure on the volume of gases and derives the relation between volume and pressure. This law was presented by Robert Boyle. He was born in 1627 and was died in 1691. He was a fellow at Royal Society London and was honored as Robert Boyle Prize for Analytical Chemistry. According to Boyle's law, pressure of a given volume of a gas is inversely proportional to the volume when the temperature is kept constant in a closed system. The volume of a gas is affected by the changes in pressure, temperature, and number of moles. So in order to find the effect of pressure changes on the volume, you have to keep the temperature and number of moles constant. Therefore, Boyle's law statement shows that the temperature and number of moles must be constant in order to determine the effect of changes of pressure on the volume of a gas. For this observation, the experiment must be performed in closed system. No exchange of number of molecules would take place across the system. According to this statement, volume is inversely related with pressure. To eliminate the sign of proportionality, we have to use a constant and use K as a constant. So equation becomes V is equal to K dot 1 by P. This can also be written as Vp is equal to K. Mechanistically, when the external pressure on the gas molecule is increased, molecules come close to each other, their empty spaces diminish, and ultimately the volume of a gas decreases. Let's prove the Boyle's law experimentally. For this, make a closed system enclosing ideal gas maintained at fixed temperature, which means that temperature and number of moles must be constant in order to prove the Boyle's law. This is a closed system enclosing the gas of volume 1 decimeter cube at 25 degrees Celsius. The external pressure applied to this system is 1 atm. In order to determine the external pressure, we must connect the system with a manometer. The working principle of the manometer is described here. The manometer encloses mercury in it and has two limbs. This is the descending limb and this one is ascending limb. When the pressure on a gas is increased, the mercury moves upward in ascending limb and downward in the descending limb, and the difference between the two limbs of manometer will show the pressure changes applied on a gas. So here this system is connected with a manometer. When we increase the pressure from 1 atm to 2 atm, the volume decreases from 1 decimeter cube to 0.5 decimeter cube, which means volume is half when the pressure is double. When the pressure is again increased 3 times, the volume of a gas becomes 1/3 of original 1 decimeter cube volume. So you can see that by increasing the pressure, volume of gas decreases. By applying the Boyle's law equation, when pressure is P1 and volume is V1, putting the value of 1 atm and 1 decimeter cube, the value of K is 1. For P2 and V2, putting 0.5 decimeter cube and 2 atm in the equation, we find the value of K again 1 decimeter cube dot atm. For third volume and pressure condition, the value of K determined again was 1 decimeter cube atm, which is showing that whatever the value of volume and pressure in an experiment, the product of volume and pressure will be the same for a specific initial volume and specific initial pressure of a gas. This is how the Boyle's law equation is proved experimentally. As the value of K remains same for this experiment, we can say that V1 P1 is equal to V2 P2 and V2 P2 is equal to V3 P3. Let's have a graphical verification of Boyle's law. First of all, in the graph 1, I have drawn a graph between pressure and volume at 273 Kelvin. Check the volume along x-axis and pressure along ordinate. You will get an isotherm. When two quantities have inverse relation, this type of curve is obtained. So Boyle's law shows this type of curve for pressure and volume. This curve is known as isotherm. Iso means same and therm means temperature. As this curve is obtained at constant temperature, therefore it is known as the isotherm. When temperature is increased from T1 to T2, where T1 is less than T2, the same isotherm is obtained, but its location in the graph is changed. It is more away from volume and pressure axis, which is showing that volume is increased by increasing the temperature. As volume and pressure have inverse relation, so pressure and inverse of volume will have definitely the direct relation. So graph 3 will be obtained, which is straight line inclined along the x-axis. This straight line inclined to the x-axis or y-axis is always obtained when two quantities have direct relation. At a particular temperature T1, this green colored line is obtained. When the temperature is increased from T1 to T2, where T2 is greater than T1, then this yellow colored line will be obtained, which is away from volume axis, which is showing that by increasing temperature, volume increases and inverse of volume decreases. Now the graph number 4 is PV versus pressure, where pressure is taken along x-axis and PV, the product of pressure and volume along y-axis. As the PV values always remains the same, but whenever the pressure condition is met, this straight line parallel to pressure axis will be obtained, which is showing that whatever the pressure is applied to the system, the product of pressure and volume will always be the same. This is all about Boyle's law. Thanks for watching.